There we go. Yep. Okay, we're on. I'll just go full screen and hand over. What's full screen already? Okay. Hand over to you, Vinny.
Okay, great. So, well, first of all, thanks everyone for coming, and it's really a pleasure to be talking to you. I was actually in Australia last month for the New Year. Such an amazing place. Me and my wife, we really had a blast. We've been to Sydney, Melbourne, and Cairns, and like trip of a lifetime, really. So can't wait to get there again. Little introduction on myself. I'm a program manager at the Windows hypervisor team. So we still call it Hyper-V. Although don't get attached to the name, like we do everything that is around virtualization inside of Windows. So we take care of Hyper-V, Windows Sandbox, containers, the other hypervisor features inside of Windows that you might have seen for security features and so on. So we take care of all those things, in addition to other things for Azure, Office, Xbox, and a bunch of other teams. As you can imagine, the hypervisor portion of the platform has a stretch on the operating system, and a lot of teams at Microsoft are using it. So it's actually a pretty big feature set that we have to take care. I'm particularly focused on containers, and today what I wanted to talk to you is what do containers mean for IT pros. I'm assuming everyone in the room, although I can't see you, the camera is pointed the other way. I'm assuming you are all IT pros, and I believe I can hear you, so feel free to ask questions. If you want to go deeper in a specific subject, just let me know, and we can either go more on the slides that I have. I usually tend to get out of the slides and go to the demos and not come back to the slides, but if we need to explain the architecture or explain something, I can easily go back to the slides and we can explain something more at the architecture level. Otherwise, I'll just go to the demos and we can see the thing in action.
Just do you want me to just get a gauge of knowledge on containers?
Yeah, I'm gonna ask that. So before I do that, let me just explain.
Get out of
the way. Pretty much on how everything worked for containers to be created. So as you can see, it works on my machine. Well, then we'll have to ship your machine, and that's how Docker was born. I mean, before I ask the question, like let me ask another one. If you are all IT pros, then you probably saw this situation. A developer develops an application, tests the application in his machine or her machine, and then when the application moves to production, guess what? The application doesn't work. So I'm not going to say raise your hand because I can't see you, but do you guys sympathize with that scenario? If you do, if you do, then you are a regular IT pro. Why does that happen? Well, the reason why that happens is because like either the application was not very well validated, because the production environment doesn't have all the requirements that the application need, or doesn't have the connectivity that the application had in the developer machine. Now it's behind the firewall, doesn't have all the connectivity that it should have. And I mean, there are a bunch of variables that actually might happen because to explain the reason why the application doesn't work in production, but it does work on the dev machine. Now, the reason why we call it container is because it's actually it's similar to what happened in the history of shipping containers itself. So what happened in the past was that the industry needed a way to standardize how to send goods around the globe. So you are a TV manufacturer, or you are a, I don't know, manufacturer of whatever goods. You need to send your goods around the globe. Well, the shipping companies, they needed a way to standardize whatever goods they wanted to send across the globe in a standard that would actually fit the shipping containers, the boats and so on. So basically what they did was they created the container standard that actually, there are two. One is a kind of exactly the half of the size of the other one. So if you are shipping something around the globe, you pretty much put it inside of a container, put it inside of a ship, and then on top of a ship, and then send it across the globe. You get to the other side, you go and open it up, and the goods will be there exactly the same way they were put inside. When you think about containers from a technology perspective, that's exactly the same thing that we are trying to accomplish. When you create a container, so the thing we are trying to solve is everything that the application needs to run whatever the environment it is, it will be inside of the container. So all the requirements, all the configuration of the operating system, the configuration of the application. So when you get the container running, it should already be running with the configuration of the application that you containerized using everything that we are going to show in a second. So it's exactly the same analogy that can be used here. So when we think about running containers, the only difference is from a technology perspective, if you are going to run this container in your dev machine or your machine or the cloud or in a test environment, the container will run exactly the same as long as the operating system running that container is able to run that specific container. That's the reason why Docker, which is the first buzzword that we talk about, is so popular. They created a standard for containers on top of the operating system that is used by all the companies using containers today. So Kubernetes, Docker, all the other buzzwords that you probably heard around containers, they use the Docker standard to run containers. So just to explain a little bit, the container itself is a feature of the operating system. Docker is just a standard on how to run those containers. And of course, just by that, you are probably thinking about, well, in that case, there are a lot of advantages of using containers. The first one is agility, because you can ship applications faster, because they will run exactly the same way. Portability, because if you run on the Microsoft cloud, or if you run on premises, or if you run in Amazon or Google, the container will run exactly the same. Density, because we are virtualizing just a portion of the operating system, not the entire virtual machine. And I'll talk a little bit about that in a second. And the rapid scale, because spinning up a container is way faster than spinning up a virtual machine. Now, when it comes to Windows containers itself, the main reason we are seeing people using Windows containers today is because they have existing applications that they need to modernize, and they want to use all the advantages of containers. So Windows containers are a great way to get applications that you have today and add all the values of containers. Marketing slide, I don't need to talk about customers using. You can go to the Microsoft customers website and see customers that are using Microsoft technology. But I mean, if you do want to see some customers, we can take that offline. I want to show the technology itself. The other thing that you folks touch base a little bit is the end of support of Windows Server 2008 and 2008 R2. Hopefully you don't have that in your environment. If you do, know that the end of support for that operating system ended in January 14th. So it's really time for you to think about what to do, get off 2008, either move to Azure because you have extended security updates in there, or get off 2008, or buy the security the extended option for securities on-prem, which is really expensive. So not really a good option there. Anyway, so the question is, how do I avoid this disruption? So with that, let me get off the slides a little bit and start showing you what I have here. So in preparation for this, what I did was I created a Windows Server 2008 machine. So if you started in IT recently, you might be shocked a little bit, but this is how we used to manage servers back in the day. And I apologize if it's too small. Windows Server 2008 doesn't really know how to handle RDP connections very well in a large screen resolution. On 2009, on the 2019 machine, it will look better, I promise. But basically, this is this is not going to work. Let me try to do something here. Use the magnifier, maybe. Yep. So this is a Windows Server 2008 machine again, and what I have here is IIS. And what I'm going to show you is the application I have running in this 2008 machine. I'll explain the VINI beer in a second here. But basically, this is a ASP.NET 3.5, so really old framework running in a 2008 machine. So the problem I have is support for 2008 machine was ended in January. I don't have security updates anymore. And I still have this old legacy application running on an old framework in this 2008 machine. And you know what my developer said, well, we're not going to keep updating this application, so good luck with that. Or even in some cases, I don't even know who the developer for this application was. All I have is the application deployed in this machine, and now I need to get out of this operating system. So just to show you what the application is, let me go to the browser. And all the machines I have, they are running here in Azure. So let me go ahead and select my virtual machines here. And I will get that 2008. These machines are running in Azure just because it's easier for me to run those in Azure, but they could be running on-prem this is for the sake of the demonstration of containers and the application itself. So if I type this IP address with the address of my application itself, this is what my application is. It's a priming sugar calculator. So one of the hobbies I have is to brew beer at home. And if you ever did that, one of the process of brewing beer is to actually add sugar to your recipe before you bottle your beer, because that's what generates more CO2 when a yeast is added. So depending on your type of beer, you have different fermentation, you have different volume of CO2 and so on. So basically what this calculator does is you select what is the type of beer that you are producing. So I like Hefeweizens, so I'll select this one. You say what is the temperature that you are going to store your beer, and I check the temperature of Adelaide. Right now, I'm really jealous because you guys are 75 degrees. If you're not familiar with Fahrenheit, everything above 70 is great. Below 70, terrible. And I'm producing 5 gallons, which is 1 gallon is 3.7 liters. So 5 gallons is a lot of beer. And that's what the website does. It pretty much says for this type of sugar, this is how much you need to add in grams, ounces, or cups to your beer before you bottle it. So here's my challenge. I have this application, and this application runs on 2008, old framework, developer is not around. So what do I do? Like, how do I get off 2008? How do I containerize this application? The first thing is to actually export your application. So what you want to do is you want to go back to your Windows Server 2008. And what you need is you need the assets of your application and some kind of explanation on how to deploy this application. So a little bit here. So what I have here, I have the folder of my application that was the application was deployed. So in the case of a ASP.NET website, all I need is this folder and the instructions on how to actually go and deploy this application in a IIS server again. So in order to validate that this application runs on Windows Server 2019, what I'm going to do is now I'm going to move to a vanilla Windows Server 2019 machine. What I mean by vanilla is this is a Windows Server freshly deployed. The only thing that I added here is IIS. There's nothing else in this image, right? And in order to deploy a website on IIS, all I have to do is right-click the full website, select the option to add an application, and then I'm going to say what is the alias, what is the physical path for that folder that I just copied from the old server to the new one, what is the application pool in case I want to use a dedicated one or a shared one. Do I need to provide some kind of authentication to connect to the folder or something like that? And then regular options for deploying an application, and I already did that for this one. So here, basically, what I have the same application deployed exactly as it was deployed on Windows Server 2008. So in order to validate that this application runs on Windows Server 2019, I'm going to select the other server I have here. I'm going to copy the IP address of this server. Public address here. Copy that. Let's put it on another tab. Let's open the calculator. And there you go. We have the same application running exactly the same way. 75, let's produce 5 gallons. And there you go. The application is still running. So right now, I didn't do anything in terms of containers, right? So I just validated that this application does work in Windows Server 2019. And this is one important point because a lot of people think that because an application is running on 2008 or 2012 or 2016, it won't work on the next version of the operating system. What happens is not a lot of the application compatibility was broken between even 2012 to 2019. So if an application runs on 2012, there's a higher chance that this is going to run on 2019. If it's running on an older version, you should try exporting the application, see if the application runs on 2019. And if it does, you have an even higher chance that this application is going to work fine inside of a container. I'll pause now and see if anyone has any questions. And before I continue here, I wanted to ask, do people understand what containers are? Any questions on what I explained so far?
Well, shaking your head, so no questions, nothing to clarify?
Okay.
Cool, no, everyone's clear. Keep going, thanks.
Great. So, like I said, I don't want to spend too much time on the slides. I want to go to the demo, but I want to really just make sure that everybody understands the concepts of what I'm going to talk about in a second. So this is what the architecture looks like when you deploy a regular server, either physical or actually usually a physical machine. You have your hardware and then your operating system on top of that. And then if you look at the layers inside of the operating system, you have a layer called user space, and that's where your applications run. And then you have another layer called kernel space, and that's a dedicated layer for the kernel of the operating system. Every application that you deploy runs in the shared space called user space. With virtual machines, before I explain containers, all you do is you take a chunk of that hardware and then you dedicate that chunk to the operating system. And every single virtual machine that you deploy actually thinks that it's running on top of a physical machine. So you dedicate memory, processor, disk, network. So all those hardware components are allocated to the VM, and then the VM thinks that it's running on top of that hardware. With containers, it's a little bit different. We keep the hardware layer, and then what we do is we separate chunks of the kernel to each of the container. So the advantage here is that you are still segregating applications, but instead of dedicating all the hardware to that VM and then you having an entire OS to that VM, you have a container running on its own user space on top of that existing kernel. So when you boot a virtual machine, you have to boot an entire operating system. You have to load all the drivers and everything else. For containers, it's all there. It takes seconds, actually milliseconds, to spin up a container. And the advantage here is each of those containers, they have their own user space, but they are segregated from each other. So I could have like my VINI website here and any other websites running. And if something happens to one container, it will not affect the other one. But more importantly, everything that was made to run inside of that container will run exactly the same way, that regardless on where you deploy that container. So let's take a look on how that works. Let me go now to another machine that I have everything set up. Where is that one? Okay, so one thing that I have to explain before I go through all the commands that you are seeing here is, for virtual machines, although you have PowerShell commands and you can deploy VMs through PowerShell, most people will use probably a UI either for VMware vCenter or Hyper-V Manager or whatever is the hypervisor that you decided to use. With containers, is a little bit different. Containers, when you deploy containers, we're probably operating with Docker, which is the standard, the company that I mentioned before. And then you interact with Docker through PowerShell or through command prompt. In the case of Windows, you'll be using PowerShell. If you are running on Linux, you'll probably be using Bash. So the first thing to explain here is the images that we have for containers. In a virtual machine world, what you do is you go to Hyper-V Manager. If you're using Hyper-V, you say new virtual machine, and then you say how much memory, how many processors that virtual machine will have, what network you're going to connect, and then you associate an ISO file usually to that virtual machine. And then you start deployment of a new operating system every time you deploy a new virtual machine. Of course, you have the option to create a template, but that template you're going to generalize. And then once you generalize, you have to install that virtual machine again and install a new operating system, right? With Docker, because of the standard that they created, every container is actually created from a image. You don't actually start a new container and then you apply the things you need, and then you go and let that container run. What we do is we use a declarative way to deploy containers, create an image actually, and then you deploy new containers based on that image. So if I select the option to run the Docker images, these are the images that I have. Now, the important thing to note here is that all these images are from Microsoft, and these are Windows images. So in order for you to get started, Microsoft already provides base images that have either IIS or ASP.NET or any other framework that Microsoft might provide. You can check all of those images that Microsoft provided in a place called Docker Hub. Docker Hub is a repository for container images. So if you want to create a web server, instead of deploying the server core image and installing IIS, Microsoft already provides an IIS image for you. Right. How do we get those images? Well, to get an image, you can use the command docker pull, and then you have to provide what is the address or the name of that image that you want to pull to your machine. When you go to the Docker Hub, and actually, I should open this here to show you guys. When you go to Docker Hub, you will see the name of the images that you can pull from Docker Hub to your machine. So let's say you want to pull, for example, Microsoft IIS. Oops. You see here the Microsoft option. I mean the Microsoft user, and then you have all the information. This specific image running Windows IIS. We have different versions of this image. So if you are running Windows Server 2016, you can use this one. 2019, you can use this one. If you're using the semi-annual channel releases, you can use one of these. So depending on the image that you're going to use, you select a different tag from the images available. And then the entire command to pull an image is actually here. If you want to pull this one, you go ahead and do it with this command. And when you do that, you will see those images listed here through the Docker images command. Now, if you want to check what are the containers that are running in your machine, you can run the Docker PS, or the Docker PS -a that shows all the images, even the containers that are stopped. So if you created a container and then it stopped, it's an option for you to go and check those containers as well. So okay, let's create a new container, and I'm gonna run this command over here. I'll run this one and I explain what's doing in the background. So basically what we're doing here is the docker run command, and the docker run command will pretty much, actually I should have used, I should have remembered this. There's a bug on PowerShell ISC. So let me stop this one and run this outside. Let me run this command over here. Just change this because it created a container already. So basically what I'm doing with this command, let me go back to this screen, is I'm going to use run to run a new container. I'm saying the name of this container is VINI beer test. And then what I'm saying is I'm going to interactively open this container. I'm saying that the base image I'm going to use is the Microsoft Windows Server Core based on the LTSC Windows Server 2019. And then at the end, what you're seeing here is what is the command that you want to run because you are running this container interactively. So if I go back here, you can see that I'm now inside of this container, right? So what this means is that just like when you have a virtual machine and you create a virtual machine and you open the connection to that virtual machine, this is exactly what I did with this container. So if I type dir, for example, on the C drive, you see that I have just a few items here. If I do the same thing on the host, you see that I have a few more drives, folders over here. The other thing to understand about containers is they are, although it's the same operating system as I explained on the architecture, it's not exactly the same. The host can see a few things from the container, but the container can't actually access the host. So if, for example, I run the get process, and the name is SMSS, this is a Windows process. You can see that I have one running inside of the container. And if I go back to the host and I run the same command, get process, name, SMSS, you can see that I actually have 3. Why do I have 3? Because I have 1 from the host and 2 from the containers. So you can see even the process ID 50 over here. Actually, the process ID is this one, 1489. It's exactly the same in here on the host. This only happens because the host has access to the information inside of the container. Now, from a security perspective, we also have a way to eliminate that through hypervisor isolation. So you have the option to create containers also with hypervisor isolation. They continue to work exactly the same. It's just that instead of the host being able to access the information inside the container, in that case, we have a completely isolation through the hypervisor, just like a virtual machine. But my point here is containers, they share the operating system, but they have their own file system, they have their own registry, and they have their own access to the memory. So the variables are also exclusive from the containers. Any questions so far before I continue?
No, all good.
Great. So let's take a look at the Docker PS again. So if I run the command, you can see that I have the VINI beer test. The first one I was running, and the second one that I just created to demonstrate working interactively with the container. Let's go here and exit the container. Just to show some cleanup, how do we do that? So if I run the Docker, and then I say what is the name of the container that I want to remove, and I actually have to stop the container first, of course. So Docker stop, VINI beer test, then Docker RM. So I stop the container. Now I can Docker RM, VINI beer test is going to remove the container. Stop the other one. And then I can also remove the other one. So now if I run the same Docker, Docker ps -a, you can see that I don't have any containers running anymore. So let's take a look at what my application looks like in this host. So all I did in this host was I copied the folder from that application to this host. You can see this is a regular ASP.NET application as it would look like. I have my my web config file over here. I have all the assets for the application to work. This is the page that I was opening for the application on the other servers, like regular deployment of a ASP.NET application. The other interesting thing that you see here is that I have a Docker file. And this is really a file called Docker file, no extension. Like there's no extension in this file over here. This is an important thing because using this file, we're going to explain to Docker how do we want our application to work. Remember that I mentioned that I would like zoom in a little bit here. There you go. So I explained earlier, all I had to do to bring this application to Windows Server 2019 is I need the minimal information on how to deploy this application on Windows Server 2019. So that's exactly what we are going to do inside of this Docker file. The only thing is containers, first, they don't have an UI. So they are all based on the server core image or the nano server image. So no UI, no way for you to open IIS and right-click your default website and so on. So what you have to do is you have to work with the command line or PowerShell to go and create your container image. So basically what the Docker file does is explain in a kind of a recipe, how do you want your application to be deployed on your container image, right? So before I explain the Docker file itself, let me go back to the PowerShell ISC and run this command over here. The command I'm going to run is the docker build. Docker build is a command to build a new container image. And I'm going to say the tag for this container image is VINI beer image. And then I'm saying use the context of the folder that I'm in order to execute this command. So let me get this going. This will take a while to run. And while it runs, you open PowerShell over here. Oh, sorry, the notepad over here. So basically what we are doing here in this file, this is what Docker is reading on the background, is command from, and then I'm saying from this image. So the first thing you want to do is you want to say to Docker, start everything from this image. And what I'm saying is start from the Microsoft Windows server for image that has IIS. So this image already has IIS. So Docker is instantiating a new container based on this image and then running all the commands that are below this from line. Okay. Then another command that I'm going to set to Docker is the working directory. And this work dir over here, it's pretty much the context of the C drive. So what I'm saying is create a folder called VINI beer on the C drive and set this folder as the working directory. Then what I'm going to do is I'm going to copy the content from the folder that I'm in on the host to the working directory on the container. Okay, so what I'm going to do is I'm pretty much copying that folder C VINI beer from the host to the C VINI beer on the container. Okay, then what I'm going to do is I'm going to run a few PowerShell commands. Why do I need to run these PowerShell commands? It's pretty much because if you get an IIS server, think about not in a container. You just deploy Windows Server, you deployed IIS. Does ASP.NET already works? Well, no, you have to also install the features inside of IIS in order for ASP.NET to work. And what are those features? Those features are the .NET framework, and then the web ASP.NET. In the case of Windows Server 2019, you are going to install the 4.5 version of the .NET framework, and then that also includes the previous frameworks.
Is there an easy way to see those dependencies?
Is your question like, what are the dependencies of my application?
Yes.
Um,
So the dependencies of that web application, so the ASP.NET and obviously IIS, that type of stuff.
Yeah. Usually that's something you will get from your developer, like what are the dependencies that that application has. The other way you can do that, you can go to the old server and check what are the specific IIS features that were installed using the. Let me get out of this real quick so I can explain. So if you get a regular PowerShell, if you run the get Windows feature, so this command lists everything. There's a way to actually show only what is installed. So everything you see an X in here is installed. So this will be one of the ways for you to check if you don't have any applications to look into what your application is dependent on. There's a bunch of applications out there. I think Microsoft has one in Azure called Application Dependency Mapping or something like that. The one I'm showing right here on PowerShell is probably the easiest way. So you can see like I have .NET Framework 4.7, WCF, like you will have to see like inside of IIS, what are the things that you have installed in that IIS deployment.
Thanks.
Usually what we see in most of the environments is the developer has at least one like Word document describing how, or someone created a Word doc describing how to deploy your application. What I'm doing here is pretty much translating to PowerShell what I would do in Server Manager or what have you. The next thing I'm going to do in this one is to run another PowerShell command to import the web administration module. Why do I need to do that? Because if I had the UI, I would go to IIS, open the default website, right-click, and deploy a new web application. Oh, I don't have that, so I need to do this through PowerShell. In order to do that, that's the module that is going to allow me to do that. So I'm going to say new web application, and then the name of my web application. What is the site that I'm going to use? I'm going to use the default website. I'm going to use the default application pool, and then what is the physical path for that web application? So see VINI beer inside of the container. And that's pretty much like if I were running on a virtual machine and I copied these PowerShell commands, this would run exactly the same way. I'm just translating what we're going to do in a UI to PowerShell, right? Any questions on the Docker file over here?
No, all good.
Great. So now you can see that the process completed over here. I'm going to run Docker images again. And you can see that I now have another image called VINI beer image, which is the name that I provided, ready to go to be used for creating new container images. I'm sorry, to create new containers. So now let's run Docker run command again, but I'm going to change it a little bit. So let's run the command so I can explain it. I'm going to use the same Docker run. It's exactly the same to run new containers. But now, instead of using the -it, I'm going to use -d. What the -d means is that instead of running this container and opening the session interactively, I'm going to run detached from the host. So the container is running on the background, just like a virtual machine. Also, I'm going to open a port from the host because for networking for containers, instead of giving an IP address, by default, what we use is we use NAT. So we give it a NAT IP address, and then we map the ports from the host to the container. The question I get is, can I actually deliver an IP address for the container? Yes, you can, but then you have to change the type of network that comes with by default when you install Docker on Windows. So I'm using the default. So I'm opening the port. So I'm using the -B. I'm opening the port 80 from the host to the port 80 of the container. Okay. I'm naming my container VINI beer, and I'm saying I'm gonna run this container from the image VINI beer image. And that's exactly what we did here. So if I run Docker PS, you can see that I have this container running in the background. Actually, the container is this one, the name of the container. Now let's test this container, right? So if I am mapping the port 80 from the host to port 80 of the container, then if I go back to the Azure portal, actually it's this one. Let's take the IP address of that host. And I'm gonna copy this IP address. Paste it over here. Let me see. That's VINI here. Calculator ASPX. For the when you launch an ASP.NET website for the first time, it takes a while for components to load. But as you can see now, the application is running inside of that container. Just show off a little bit. Let me do something else over here. So I'm going to start Task Manager. I'm going to put it on the side here. And I'm going to put this one on the other side. So now let's look at the performance of this host. And I want you to take a look at how much memory we are using to spin up another instance of this container image. So if I click play over here, I'm now running another container called ViniBeer1. I'm mapping the port 8080 to the port 80. And as you can see, to spin up another instance of this container, I am using just, I don't know, 100 megs more, maybe. And I can actually go and spin up yet another one. And again, not much more being used from this host. Now think about this. If you're going to run another instance of your web application, even if it's just that web application that doesn't use much, doesn't use a lot of resources, in order for you to run a new VM that has another operating system, that has all the configuration for the operating system, plus the fact that you have to manage that entire operating system, you have to backup, you have to update, you have to do all the maintenance work that you guys are familiar with, that will be a lot more resources in terms of hardware, in terms of people, and so on and so on. In this case, I'm running 3 instances of my website. So if I run the Docker PS again, I have 3 instances of my website running in this host using different ports. And just to show that these applications are still running, I'm going to change the port over here. So the first one is 8080. It should load in a second. There you go. The next one is 8081. And it's also loading exactly the same way. So there you go. Like this was a very straightforward, very easy way to take an application that was running on 2008 or 2008 R2 in my case, validate that the application runs on Windows Server 2019, and then the same way you would deploy this application in Windows Server 2019, you actually pass the instructions via Docker file, and then you can run new containers based on that container image that you created with the instructions of the Docker file. I'll pause here for a second. I have one more thing to show you guys before we close. But I'll pause to see if anyone has questions. Okay. So the other thing I wanted to show you is, well, how do I manage this container? Okay, the container is running, but how do I know that the application is running? How do I see inside of the container? One of the options is, just like I showed you how to open the container interactively, you could do that. What you end up with is a server core image. So basically, you have all the PowerShell commands that you are used to. Another way you have is what I'm showing you right now is Windows Admin Center. I hope you are familiar with Windows Admin Center. If you are not, Windows Admin Center is a new management interface for Windows Server that allows you to use the regular tools that you are familiar with, like, for example, certificates, devices, events, files, firewall, everything that you would use in the old MMC. We are now bringing to Windows Admin Center in a way better option to manage Windows Server remotely and with a beautiful UI. One of the things we have here is the containers extension. When you target a node that is running containers, you can also manage those containers using Windows Admin Center. So when you open the containers extension, you get a nice summary of what you have running. You have the list of containers that you have running that node. So remember that I had 3 containers that I showed on the Docker PS. I can see exactly those containers right here. So if I open one of those, for example, the VINI beer one, I can see the stats for that container. I can see how much CPU that container is using, how much memory, how much network that container is using. I can see some details for that container, like, for example, what are the ports that are opened for that container. I can see the image that this container was created, and so on. But the thing that I like the most is for Windows images, we added this events option over here. If you ever used Event Viewer, you will like to see the way we show the events for containers on the left-hand side over here. It takes a few seconds to load, especially because I'm running this host in Azure and I'm connecting remotely to this host. So if you ever used Event Viewer, this is exactly the structure that you get on Event Viewer in a regular Windows deployment, right? So if I go to application, you can see all the logs that an application will write to Event Viewer inside of the container, just like the application would do in a regular deployment of Windows Server. Like I said, it's taking me a while to load because I'm doing everything remotely, but it's exactly like you would find the information on a regular Event Viewer. So it makes it easier to manage containers, even though they don't have any UI. So this makes it easier to do that. The next thing I wanted to talk about real quick before I close is that Microsoft has other options on Azure for you to extend and go beyond just running containers. The first thing you should know is that all the images that I have stored on Docker Hub can also be stored in your own private repository. In Azure, we have a service called Azure Container Registries. So Azure Container Registries allows you to create your own repository and set what are the requirements and configurations for someone to store images in there. And then only your company or you or the allowed people will be able to download images or push images from that repository. So what I did previously, I created this repository. And if I open the repository's services over here, you can see that I have exactly the image that we created right now already stored in this repository in Azure. I actually have the tag v1 in this case. And in fact, I can even click this option over here and select the option to run an instance of this container on Azure itself. Now, the moment I click this, what you see here is the container instance. This is another service on Azure. So if you just want to run this container instance in Azure, you can select what is the container name you want to give. It already brought what is the container image that you are going to use. The OS type in this case is a Windows container. Regular stuff from Azure, like for example, what is your subscription, what is your source group, where you are going to deploy this, and then how many cores the container will get, how much memory the container will get, if you want a public address for this container, and if you want to run port 80, for example, on this container. You click OK, and it will deploy a new container. Well, let me show you what this looks like. If I go back to the dashboard, we have another service here called container instance, as I mentioned, and I previously created one called VINI. So it's the same that I showed you before, but it takes a few minutes to spin up this container for the first time in Azure. So this one is already running. If I get the IP address from this container running on Azure container instances, and I go to the browser and run exactly the same thing as before, I have the same application now running in the same container, but now in Azure. So remember that I said the container will run exactly the same way, regardless on where you deploy the container. This is what this means. This application is already running. I don't have to configure anything inside of the container. I only have to provide the container image. The container will run exactly the same way. Now, of course, this is running only one instance of my container, okay? What about high availability? What about load balancing? What about scaling up the application in case I get a lot of traffic? Well, in that case, that's where an orchestrator comes in. And you probably heard about Kubernetes. Kubernetes is a container orchestrator. Kubernetes deal with all the operations that you are probably familiar with cluster, like for example, high availability. How do you configure load balancing? How do you configure replication for your hosts? How do you configure all the options that you would need in a larger environment rather than just running one VM or one container? Kubernetes itself, it's another word, needs a lot of explanation and needs a lot of understanding of the architecture and how it works. So my recommendation for you is get familiar with Windows containers, understand how Windows containers work. We have a lot of documentation, and in fact, let me move to this. This is where I will recommend you all to go, aka.ms/containers. This is where you can get all the information like how to get started, how to deploy the containers feature on Windows, containers orchestration with Kubernetes for Windows, explain a little bit about Docker. If you have a Windows 10 or a Windows Server machine, we have all the information on how to deploy that. And with that, I will end up my presentation, but I'm still here to answer any questions you might have.
That's great, thanks. Is there any questions for Vinny? No? Cool, right, we'll wrap it up there. Thank you very much, Vinny. If anyone does want to contact you, what's the best way? Through Twitter, get your Twitter account there, or anything else?
Yeah, I mean, let me type my email address. If you folks have any questions, feel free to contact me on email. If you want to follow me on Twitter, I usually put some information in there about the blogs that I've been writing, some news around containers. But if you have any questions, send me an email. Happy to take any questions offline as well.
Great. Okay, thanks very much for that. Next month we've got PowerShell 7.1 or something.